Good evening. Welcome to the Not Bad News Network. I'm Erin, and tonight I'll be sharing some stories of not bad news with you. First up, we'll be talking about new discoveries in the effects of air pollution, then an interesting article about mitigating methane gas, and finally, a little bit about otters and their ecosystems. So first up, air pollution deaths in children under 5 down 35% since 2000, a global report. Researchers have published the State of Global Air 2024 report, which presents data on exposures to and health impacts of common air pollutants, including fine particulate matter, ozone, and for the first time nitrogen dioxide from 1990 to 2021. The report finds that while air pollution was the second largest risk factor for death for children under 5 in 2021, the death rate from air pollution for this group has decreased by 53% since the year 2000. The report is a collaborative initiative of the Health Effects Institute and the Institute for Health Metrics and Evaluation's Global Burden of Disease project. Its 2024 edition was produced in collaboration with the UN Children's Fund. The report finds that air pollution was the second largest risk factor for death in 2021 after high blood pressure, accounting for 8.1 million deaths globally. Of these, 58% were from ambient fine particulate matter, 38% from household air pollution, and 6% from ozone. Countries in South Asia and Africa bore the highest disease burden. The report's findings show that while ambient fine particulate matter levels are decreasing or stabilizing in many regions, populations in low-income countries and middle-income countries are exposed to up to 4 times higher levels of ambient fine particulate matter. Since 2000, the disease burden for household air pollution has decreased, driven largely by reductions in exposure in China and South Asia. Deaths from household air pollution dropped by 36%. According to the report, air pollution is responsible for 30% of deaths from lower respiratory infections, 28% of deaths from ischemic heart disease, and 48% of deaths from chronic obstructive pulmonary disease. Its findings reveal that lower respiratory infection deaths are declining in most regions. In children under 5, air pollution is only second to malnutrition in terms of posing global risk factors for death. In South Asia and East, West, Central, and Southern Africa, air pollution is responsible for almost 30% of all deaths in the first month after birth, the report finds. Air pollution has enormous implications for health, said Health Effects Institute President Elena Kraft. We know that improving air quality and global public health is practical and achievable, she underscored. The global estimates presented in the report seek to support local and regional data and evidence-based decisions, policies, and actions. Next up, we've discovered the world's trees absorb methane, so forests are even more important in the climate fight than we thought. Tree bark in the world's forests absorbs the greenhouse gas methane, a discovery that could have big implications for tackling climate change. As trees photosynthesize, their leaves take up carbon dioxide and lock it away as biomass in their trunks and branches, providing a long-term store of carbon. But now our large-scale study proves that there's another way that trees absorb greenhouse gases, so forests can provide even more climate benefits than previously thought. Methane has contributed about a third of the observed climate warming since pre-industrial times. Concentrations of methane in the atmosphere have been rising rapidly for the best part of 2 decades. That's a real problem for Earth's climate because methane traps much more heat in the atmosphere than the equivalent amount of CO2. But while CO2 can last in the atmosphere for hundreds of years, methane has a lifetime of about 10 years. The short atmospheric lifetime means that any changes to sources of methane or processes that remove methane from the atmosphere, called methane sinks, can have rapid effects. If removal is enhanced, this can be quick climate win, helping to mitigate escalating climate change. That's why researchers are so interested in understanding how methane gets into the atmosphere and how different processes remove it. Wetlands are known to be the primary natural source of methane. Trees and swamps and floodplains can emit methane from the lower portions of the trunks, but methane exchange in trees growing on free draining soils that don't flood, that includes most of the world's forests, has not been well studied until now. We measured methane exchange on hundreds of tree stems in forests along the climate gradient spanning the Amazon and Panama through to Sweden and forests near Oxford in the UK. We used a simple plastic chamber that wrapped around the tree trunk, which was then connected to a larger base methane analyzer. At first we looked for methane emissions from trees, and some do emit a small amount from their trunk base, but the surprise happened when we measured higher up in the trunks. Trees were taking up methane from the atmosphere, and this methane removal grew stronger the higher up we went, with methane removal from the atmosphere dominating overall exchange. Next, we investigated whether this was a globally important process. To do this, we needed to calculate the global area of tree bark. Using a technique called terrestrial laser scanning, we mapped tree woody surfaces down to the finest twig. We discovered that if all bark from all the world's trees were laid flat, it would cover all of Earth's land surface. Potentially, this represents a vast area for gas exchange between tree bark and the atmosphere, but this mechanism is still poorly understood. Clearly, decarbonization of the global economy and energy system is the key way to address climate change, but this capacity for tree bark to absorb methane offers another angle of attack as a nature-based climate solution. There may be new ways to improve methane uptake in plantation forestry by selecting trees that are particularly good at atmospheric methane removal or modifying tree bark microbial communities. Nations could be given greater incentives to preserve existing natural forests and avoid further deforestation. Expensive reforestation projects may become more economically viable under reputable carbon offset schemes that consider methane. This new evidence reinforces the importance of trees and forests for our climate system, while demonstrating that there is still much to learn about these valuable ecosystems. This story gives an overview of the work of Vincent Gauci, who's a professorial fellow from the School of Biology, Earth and Environmental Science at the University of Birmingham. And then last tonight, our story about sea otters. Sea otters have become the unsung heroes of the sea simply by snacking on sea urchins. Sea urchins are prickly hedgehogs of the sea that exist in every ocean around the globe. You might have seen their spines peeking out of the water during low tide, or even stepped on one while swimming, but their presence in small numbers is good for the environment. They graze on algae, which helps coral reefs thrive. But it is true that you can have too much of a good thing. When sea urchins overpopulate the seafloor, they mow down any algae and kelp in their path, even destroying entire kelp forests. These forests under the sea serve as protection for over 1,000 species of fish, crustaceans, and invertebrates, including sea stars, anemones, and jellyfish. When kelp forests disappear, the animals that live amongst them disappear in turn, taking critical food sources away from bigger marine life like sea lions and whales. There's even a climate cost to losing kelp forests, now that scientists have discovered that kelp forests temporarily store roughly 20 times more carbon per acre than wooded forests on land. Fortunately, sea urchins have emerged as the unsuspecting Fortunately, sea otters have emerged as the unsuspecting heroes of the sea. By snacking on sea urchins, they keep urchin populations in check, which is good because sea otters are pretty hungry for fluffy 4-foot-long carnivores. To stay warm, sea otters eat a quarter of their body weight in food every day. In addition to sea urchins, they eat crabs, sea snails, clams, mussels, and slow-moving fish. To crack open their hard-shelled prey, otters will forage for sharp-edged rocks and use them like anvils to open food. Sometimes they can even rip dinner apart with their dexterous little paws. But researchers are slowly realizing more and more just how important sea otters are to the environment. In fact, researchers pored over a century of ocean maps. I apologize, I'm having trouble reading tonight, but let's continue. In fact, researchers pored over a century of ocean maps and proved that wherever sea otters live and have lived, the ocean has been better off for it. In the study, published in PLOS Climate, lead researcher Kyle Van Houten said that increased otter conservation and less human activity can have an impact which cascades throughout the ecosystem. Marine ecologist Brent Hughes has studied otters' impact on the environment, especially in the area between Monterey and San Francisco. He says another way that otters help the ocean is by feeding on destructive shellfish like the striped shore crab. These crabs dig into mud and sand along the shoreline, eating pickleweed and leaving marsh grass areas looking like Swiss cheese. This in turn increases coastal flooding. Otters don't completely reverse erosion, but slow it down to natural levels, Hughes explained to VOA News. To keep the ocean thriving in a number of ways, conservationists want to help sea otters thrive too. There are 3 subspecies of otters: the California sea otter, or southern sea otter, the northern sea otter, and the Russian sea otter. While the Russian sea otter species is considered stable, the California sea otter is listed as endangered under the Endangered Species Act, and a subset of northern sea otters are listed as endangered off the coast of Alaska. Fortunately, sea otters have been making a comeback in California, and the ripple effect is extraordinary. In a scientific study published in Nature, a team of conservationists and marine ecologists concluded that sea otters' reintroduction to Central California slowed erosion of the area's creek banks and marsh edges by 69%. In this instance, restoring the otter population was achievable through sustained conservation efforts, and as a result, we are now unlocking several decades of benefits, said Christine Angelini, one of the authors of the study. This specific conservation effort to save California sea otters stretches back to the 1980s, and marine biologists couldn't be happier about the study's resounding success. It would cost tens of millions of dollars for humans to rebuild these creek banks and restore these marshes, Brian Silliman, marine biologist at Duke University's Nicholas School of Environment, told Center for Coastal Solutions. The sea otters are stabilizing them for free in exchange for an all-you-can-eat crab feast. For Angelini, climate change challenges and broad species decline can sometimes feel unsurmountable, but research like this gives her hope. This study indicates to us that if we truly understand the ecosystem and know what levers to pull, we can see significant benefits to the health and stability of these systems, Angelini said. Well, that sounds like some not bad news to me. It's all the not bad news I've got for you tonight. Until next time, I'm Erin signing off and reminding you that not all news is bad news.